Okay, hi. RTC, real-time clock. Here we have the RTC 1302. It have VCC, ground, clock, data, and reset pin to communicate with. We go through the software and hardware briefly, not in details so much. So we are connecting the RTC to a PIC microcontroller. In this case, you can also connect it to Arduino. This is PIC F628. And it go like this. VCC and ground, it's 5 volt and minus. It can go down to 2 volt, but it's okay with 5 volt. The clock pin is connected to RB1, the data pin to RB2, and the reset pin to RB3 on the PIC microcontroller. It is not a lesson about PIC, so if you want to learn PIC, please comment me down below. So this is the hardware that we need. Supply voltage and 3 pins to communicate. Now let's see what we can do with it. We go to PIC Programmer, Tools, UR Tools, Set, Clear Screen, VDD, and Connect. And we can see that we are reading the time. Okay, let's disconnect it and look at the software side. In the software we are okay, this is the ISR. We don't use ISR now. This is the main. We setting the input output bit to pin 6 of A is input, because we have here a button switch, and pin 6 of RB is also input for communications with the COM terminal. We don't use ISR, so we taking off intcon JE. This is the main loop of the RTC. Setting the red LED and the green LED and setting them off and continue. Clearing the buffers that we need or the register that we use, and this is the command that we want to send to the RTC. It's 83X, I think. It's reading the hours. This is the command of reading hour. We want to read this location in the RTC and put it in this register. Then we call a routine to print the hours, and to point again, cleaning the register. And now we want to read the minutes, so the register is 1. With 1 to read this register, we sent it to the command RTC read this location, tag and put it in this register and print second or minute. Also, this is for the hours. Now for the routines of the RTC. We are defined the location of the ports, reset in port BFS, start in port B, clock in port 2, and print second or minute. It's the same routine. We're taking the reading that we got in the command. We separate the lower 4 bits with an AND command, and we put it in a temporary register, tag 1. Then we rotate it to the right 4 times and isolate the 3 bits. Now that there was the 4 upper nibbles, now they are in the lower nibbles, and we want to read them to the minutes and put it in the count SL. After that, we put in the count SH and point tag, which is the hours in this case. The same we are doing with the hours and with the minutes. We are selecting with the end the bits that we want to read. In this case, the hour is in 24 mode, so we need the 5th and the 6th bit and the lower 4 bits, and we print them down. The RTC read command. First, we are initializing the data input output to output, so RB, so we can send data to that pin. We initiate the clock to 0 and reset to 0, and we start the sending command with setting the reset pin. Then we read 8 times the var, which is in case it's what we want to read. Is the location that we want to read, and we send it to the RTC. We rotate it to the right and checking the C state. If it's 0, we zero in the dot command, BCF. If it's 1, we set in. And we're making a clock operation, which is up and down with a delay. 8 times. We're sending the command that provide the location we want to read. Then we want to read what in this location. In order to do this, we need to put that pin to input. So we are making this bit 1. And we're reading 8 times. We are making this loop 8 times to read the data pin and put it in the corresponding place from 0 to 7, and we can read the RTC. And again, we go to this, we connect, and this is what we ended up with. Thank you.